Welcome to SIM 338, Opalis and the internal Microsoft adoption story. My name is Adam Hall. I have the great pleasure of being the technical product manager for System Center Orchestrator and what was previously Opalis. With me on stage is Charlie Satterfield.
Thank you, Adam. So I'm Charlie Satterfield. I'm part of the Management Platform and Services Delivery Group at Microsoft. That's actually part of the Management Security Division. We produce System Center products as well as Forefront. We are an operation team inside of the product group. What I want to share with you today is some of the real-world stories that we've developed within our group as well as other IT operation groups within Microsoft. I have a couple scenarios with some examples I'd like to go through, and then I'd like to talk a little bit about how we went about approaching Opalis, how to analyze our environment, figure out what we wanted to use it for, how to deploy it, and what it's like to operate.
So, we've got quite a small crowd, so please ask questions. You're probably going to see a lot, or you are going to see a lot of slides from Charlie. We can talk for 75 minutes if that's what you want, but I'm guessing you're going to have a lot of questions for Charlie, particularly about the way we approach some of the challenges. So please ask questions. Have little squeezy balls for anyone that asks the question. If you fall asleep, I'm also going to throw them at you, so that should keep you awake. But please ask questions. We will answer them as honestly as we possibly can. Okay, so keep it interactive. If you do have a question, can you go to one of the microphones or yell it out, and I'll repeat the question. Thank you.
I want to apologize for the odd configuration of the room, but I'm very glad that you're willing to test my skills by sitting on both sides of the room. So I promise I'm going to try and get to both sides of the room and not ignore the middle. We'll see how I do. Anyway, we're going to conclude with lessons learned and then any more questions that you have. First off, how is Microsoft using Opalis? We're using it right now in three core scenarios. The first being administration, things like patch management. The second being VMM and role provisioning, provisioning VMMs and then provisioning any system roles on top of that like config manager. And then the third being SR fulfillment and IR remediation, a service request or an incident request. Who is using Opalis at Microsoft? At Microsoft, we've got many different operations teams, MPSD just being one of them. So MSD is using Opalis, but we also have MSNBC.com using Opalis. They've actually been using Opalis since the robot days for many years. And then lastly, just recently, Xbox Live started using Opalis. And we'll cover one of the scenarios that they just put into production. MPSD. So I covered a little bit about what MPSD is, where we sit organizationally. We do client management, and we also do server monitoring and management. We use a lot of different products that we need to orchestrate. On the client side, we manage over 280,000 desktops. That's a lot of desktops to manage, a lot of desktops to roll patches out to. On the server side, we monitor and manage over 4,500 servers. As we look at the scenarios that we've implemented, one of the first scenarios that we implemented in MPSD was an operational readiness scenario. Now this runbook, this falls under the administration scenario. And operational readiness to us means that a server has all the agents on the box, so the config manager agent, the operations manager agent, and any integrated lights out components. So for us, we have a readiness goal, a general readiness goal, that all our servers, greater than 95% of our servers, must be operationally ready. And that means they've got agents on them, and our systems are communicating with the agents. Previous to us automating using Opalis, it was a combination of automation and manual process to determine which servers were unhealthy. They were either newly installed servers, or they were renamed servers, or they had an agent that just wasn't communicating properly. And then the ability to take that information and go install the agents or remediate agents was a manual task without auditing, without that kind of tracking. It was most of the communication was done in email. And then again, the escalations when something failed were in email. After we automated, we're looking at almost a completely automated process from discovering machines that are unhealthy all the way through escalations if agents are unable to install correctly. And the benefits here are that we get that rich auditing approval. We're no longer touching the machines manually unless we require a machine to be rebooted that we don't have ownership of. And I'll talk to that in the scenario flow. For operational readiness, on the server side, we manage machines in several untrusted domains. The first part of actually getting the information that we need involves running an Opalis workflow to identify those unhealthy machines. We actually have action servers in each of those domains so that we can run our runbooks in each of those domains, gather the information, and then we bring that information back to our central Opalis instance, and we're able to act on it. And we're able to do this because of the Opalis data bus. Next, we leverage System Center Service Manager, and we actually create a change request. From there, we begin the installation. Now, this is a high-level summary. In the installation process, there are occurrences where we need to reboot a server. There might be a pending file rename or some other instance that causes the server to need to be rebooted before we can install. We don't own every server that we monitor and manage. There are some groups like Windows Update that have physical control over those boxes. We actually assign tickets in Service Manager automatically that go out and ask the WooMoo team to actually go and perform that reboot. And once they update that ticket, our process continues.
That's how many people are using some sort of automation tool in their environment today, whether it's Opalis or others? So it's a common question that I get, which is, when you talk about automation, is it end-to-end, everything is automated at a system level? And the answer is no. It is quite okay to have this kind of gap where you automate a certain level of system-level process, and then you need to wait for someone to say it's okay to continue. That is still automation because you have automated the top-level process, but you've broken down into some system-level stuff, some business process, and then some more system-level stuff. And it's quite okay to have these gaps. When we talk about fully automating something, it doesn't mean that you have to have everything fully scripted, fully automated, works completely without touch. In some cases, that is a bad thing. And it's over to you guys to work out at what point in time do you fully automate at a system level, and when are those manual steps required to pause and wait for a human being to make a decision point. Okay, so that's quite common and quite okay. Question?
Are you jumping in and out of the workflow then?
Are you jumping in and out of the workflow? Can you clarify that question a little bit?
I know what you mean. So the work, it depends on how you've created the runbook. I believe that you guys have broken the runbook down into bite-sized chunks. So one runbook will end, but a second monitor is polling to see the result come back. So
it definitely does depend on how you coded it. I'll show you some snippets as we move along here. This is one of our first runbooks that we deployed to production, so it's not as componentized as we might like.
But that is the best practice, is that you break it down so that when you finish a runbook, it writes out all the data that you need at a later point in time, and you have a second runbook that is sitting there polling to wait for that response to come back from wherever it is. Whether it's a change request and Service Manager clicks over to approved, whether it's a file changes, whatever that change is, monitor for that change and then start another runbook. Otherwise, all that happens is on your action servers or runbook servers, as they're known moving forward, you just got more and more monitors or runbooks executing for no good reason, soaking up resources. Close it out and then kick off again. Good question.
All right, as we're proceeding, between each of our tasks, we're updating Service Manager, we're updating the change log. This is providing that rich auditing that allows us to go back and figure out what's happened if there's a failure. We're remediating known failures. This part is not yet in production. We're still in development on it. But because we're in Service Manager and because we have the ability to actually look at the results that are coming back, we have some known issues that we can go remediate automatically. Lastly, we can escalate those issues in Service Manager if we're unable to remediate. And then we close the change request in Service Manager if everything's been successful. So the next two slides I'm going to show you are snippets from the overall workflow. And the one that I really want to show you, which is really messy, is this one. Now, this was the first run book that we put in production. It's messy, but it works. It works very well. How easy do you think this is to maintain? No, not so much. So as I go through the presentation, you'll notice that the run books are becoming more and more componentized, and we're following more of the best practice of breaking down unique tasks into distinct policies.
How far in your operational life cycle did you realize you had to remediate?
So the question was, if you couldn't hear, how far along in our operational process was it that we discovered we needed to remediate that and actually go towards componentization? And it was really within the first 2 months or so, we realized that we weren't going to be able to maintain what we were writing if we kept writing it the way that we were doing it. Now, our first couple workflows, we didn't have a good process down yet, and after that first couple months, we started really identifying how to break things down. Identifying your business process and really getting that tight is the first step.
A lot of the language that we will be releasing with Orchestrator are a lot more guidance around how to do these things and a lot more best practices. And quite honestly, a lot of the content that's coming out of the documents that I'll be releasing is coming from Charlie's team working through this in a real-world scenario of trying it and learning what worked and what didn't. And that's the whole point of doing the internal dog fooding that we do, is that we learn what works and what doesn't. We document that up so you don't go through this kind of pain, which is what we're trying to achieve here. Question way down the back.
When you start putting your workflows into production, how are you doing change management with the workflows themselves? I mean, anybody can check in and check out and it's working.
I'm so glad someone asked that question.
Change management is a challenge. We are trying to implement some practices whereby we're exporting our workflows and we're checking them into Team Foundation source control. And we're trying to maintain master changes there. We don't want somebody in production making changes, right? We want development and testing to happen on test systems or pre-production systems.
So this story is not great with Opalis. It's not quite so much better with Orchestrator. It is still a process of export, import, going through a cleansing process. We are working on a post-Orchestrator release that will have some sort of change management, hopefully, and making it easier to roll through the dev test process. But to be honest, it's still an export-import process with Orchestrator.
Our next process that we're automating, actually it's not quite done, it's in test right now, is our Desktop Patch Tuesday process. And this again falls under the administration category. Our desktop patch process is a 4-part process. It runs monthly. Who in here manages patch processes for their company?
We're sorry.
It's not fun. It's the same thing every month. The only thing that changes is the variables. What are you distributing out, and whether or not it's an out-of-band or a regular release cycle. On our side, there's lots of handoffs between teams that are expensive. There's multiple tickets involved. It's an ugly process to run manually and one that begs for Opalis automation. As we look at what we're looking to achieve with automating this, we've started with our desktop Patch Tuesday process, which is the second step in our 4-part process. It will streamline the 4-part process when we've got the entire end-to-end process done. But we'll be able to standardize this across customers because we support multiple customers. When we looked at developing our business requirements, so as we're looking at some of our really main workflows, we're spending a lot of time developing our business requirements around it so that we end up with a very good product at the end. And on our case, some of the requirements were it needed to scale to 280,000 plus desktops. It needed to support multiple customer environments. And it needed to be able to orchestrate process, people, and technology. Like Adam mentioned, in some cases, you want a manual handoff. You want that checkpoint. We next developed a functional specification, and we updated our patch process flow. When you look through your business processes today and you look at how you need to automate them, you may actually update some of those processes. You may find that they're not optimal. We next looked at what requirements we had and whether or not the config manager IP in Opalis 6.3 would meet those requirements. We identified some gaps, and so we started working with the Opalis orchestrator product group to fill the gaps. The result of that is that we're working on a community IP. Now, this community IP is still in the last stages of testing, but it should be released in the next month or so. As you can see, it includes a lot greater list of activities than the out-of-the-box 6.3 config manager IP. Now, we didn't request all of these, but the orchestrator product group is actually going above and beyond and creating a very nice story for Config Manager 2007 support. Looking at our process and how we automated it, part of our business we run ticketing out of Team Foundation Server. Another part of our business we run out of Service Manager. We haven't been able to combine the two worlds yet. For this process, we run our business out of Team Foundation Server, and we cut our tickets there. We're leveraging a Team Foundation Server IP that was created internally. There may be plans, I believe Adam and Rehan have talked about shipping the TFS IP. You said I could say that. Don't back down on me now. So we're able to actually monitor TFS for new work items, right? There's a monitor work item action. We're able to monitor for those new work items and meet the query criteria, and then we're able to map the data in that TFS work item to the data that needs to be passed to the rest of the process. If it passes the criteria, we set the work item to approved, and we actually start our process. First part of our process is synchronizing SUP. Within SUP, there's a couple different components. We actually have to monitor both our main sync as well as any down-level server syncs. Now, it's important to note that high-level orchestrator, so let me go back here. This is sort of the high-level orchestration workflow, and each of those is triggering sub-workflows.
This is where Charlie was talking about that first one being one big Uber workflow and then starting to chunk it down. If you look at the screen, each of the little red, yellow, and blue symbols there is actually triggering a sub-run book. Okay, so this one's been chunked down into a number of different portions that's going off, running a subroutine, coming back, running another subroutine, coming back, which gives you the restartability and the ability to not only restart, but also have a much easier way of understanding what's going on. So it's one of the learnings that came out.
Now, each of these triggers, when it triggers those sub-policies or sub-run books, it's waiting for completion. So when we go into the sub-process, there's, again, two triggers within this run book that trigger those sub-processes again. And each of those, again, are waiting for completion. Once completion is attained, we move on to our next item in the workflow. And in this case, it's deploying updates, which is creating the packages. So in this policy, we're actually creating our packages. We're leveraging two technologies here. One, we're leveraging some of the Config Manager community IP. And then secondly, we're leveraging PowerShell. You can actually put PowerShell scripts within the Config Manager IP. I believe it's the .NET Run object. And it will run just like it was running previously as a commandlet. So when this completes, so in this process, we're creating our package, we're creating our update list, and then we're creating that update deployment. Now, when that's all completed, we're setting our work item to created. And now we're waiting for QC. Now, this is another process where we actually hand off to a manual function. We're setting the work item, and we're sending email to an administrator who has the power to actually approve the deployment. When we go to deploy to 280,000 desktops, we don't really want to automate the full thing until somebody's gone and approved and tested the first 3 or 4 run-throughs and made sure that it is doing what it's supposed to. Otherwise, we've got a mess on our hands.
It's a good example of someone having ownership of that approval, and ultimately someone is responsible for saying, yes, that patch can go out to 300,000 desktops. That is something you do not want to have fully automated. You want someone to say yes. Sorry, can you say that a bit louder or step up to the microphone? I can't hear you, sorry. So Orchestrator and Opalis support running tasks against non-Microsoft platforms. There is an SSH command. If there's a platform you can hit, the answer is yes. How you deploy on the Linux box. If it's an RPM package, for example, you can run that through the SSH command. So whether it's going through Config Manager or whether it's going direct, so long as there's a way you can trigger it and automate that particular task, then the answer is yes.
Intercepted. All right. So at this point, we pause the process. Once the process is approved, once the deployment package is approved, that user, that administrator, updates the work item in TFS. Now you see the next, right after we send email, the next action is actually querying TFS, and it's looping. Right? In this case, the developer, or the engineer that wrote this didn't use the monitor TFS action. He instead used the query work items, which provides the same functionality, except he needs to establish a loop so that it keeps checking. Once it determines that the patch has been approved, it queries the work items, and then we roll out to distribute. At distribute, it again calls a subprocess, which should have propped up. Okay, problem with the slide. At the end of the entire process, we go ahead and close the TFS work item, and our patches are now being deployed. We actually have one of those processes is not set to wait for completion. It's actually out there running and monitoring our replication. Right. So that's our patch process. Any questions? We got 2. You're down front first.
Not related to patching necessarily, but how are you monitoring the actual workflows themselves as far as if one of those were to fail? Do you have some sort of, are you using like operations manager or something like that?
Currently, we don't have a strong story around that yet, but we can detect failures in a number of ways. If we have a failure within the process itself, I've got Jim Britt down here is one of our engineers, and in this next example, actually, we can show a little of the PowerShell he has integrated. And if it fails along the process, we go ahead and update a ticket, right? We create a ticket in TFS so that we know that something's failed, right? I'm sorry. So the question was, how do you know if something failed, right? How do you know if the policy or the process failed? And it's all about how you create the process. So you can monitor, you can write some reports against the database, right? And look to see what has failed or succeeded. But in our case, we chose to actually implement some more auditing through creating TFS work items or bugs when we actually fail.
Now, this session actually comes before my overview session tomorrow, but Operations Manager, we will have an Operations Manager management pack for Orchestrator at release. Okay, so there's not going to be one for Opalis. The management pack will come out around about release candidate of Orchestrator timeframe. We have one internally that we've been using for a little while that we created, and it's going to be built on from there. So.
There is a management pack that's been created by an MVP that is out there. We have not used it yet, but it is in existence.
Are you going to have community supported management packs like you do with Stomp?
Sorry?
Community supported management packs where you actually create various packs?
You mean integration packs for Orchestrator? So you can do that today. There's a number that are out there on Codeplex and on the Technic Gallery. If you want to create an IP and post it up with or without source code, you can do that today. Do we support them? No, we didn't build them, so we don't support them. But we certainly reference the fact that they exist, and we promote that, and we provide all the tools for you to create integration packs. It's not hard, even I did one, so it's really not that hard at all. So if I can create one, you guys can as well. And I'm going to talk about that tomorrow. We've actually got a question over
Yeah,
here.
we got
Sorry.
one more question over here. I don't think so.
Yes.
Go ahead.
So you mentioned PowerShell. You may go into this later on, but the automation tools I use, you have to kind of modify the PowerShell script to accept external variables. For your tool, can you just lift and drop a standard PowerShell script as is to accept external variables?
Do you want to come up and talk about that, Jim?
Yeah. I think Jim, come up and talk
Come on
about
up.
that up here. Jim knows a lot more than we do. So the
Yes.
simplistic answer is that,
All right.
yes, you can copy and paste PowerShell code into an activity that is the run.NET script, and you can execute PowerShell code there. You can also parameterize your PowerShell script so you can run it in a PS1 file and pipe in the parameters. Now, if you do that, you can turn that into an activity through the Quick Integration Kit and create that PowerShell script as an IP. Okay, so there's some benefits to doing it. But
So the question for those that didn't hear was, do you need to modify PowerShell scripts in order to pass in
Grab the mic.
variables?
So I think this example would be, on one operator, I've got a variable computer list.
Mhm.
The previous step is what is creating that list.
Yes.
That's kind of what I'm saying.
So we'll actually show that in this next section here, but go ahead, Jim. If you,
I think you guys have a question, actually, so, but,
we have to get down low.
is that one not working?
no, I don't think it is. But basically, the published data that's flowing through can either be inputs coming from, in our case, in the example, TFS or Service Manager, and those can be just dropped directly into the scripts themselves dynamically. So we're leveraging the published data on the data bus to send those through. Not sure that was answering the question or not, but, yep.
Thanks, Jim.
Thanks, Jim.
All right, great questions. Let's move on. So the next section is our config manager role deployment. So this one, Jim is actually developing right now. We're just about done with it. And it's meant to help our deployments of config manager secondary sites as well as distribution points to some 130 servers worldwide. Step through these. So much like in our patch example, we're trying to automate a process that has a lot of manual steps as well as a lot of email exchanges. Not as much auditing in that process as we need to be able to create a successful process. Let me jump over to our Opalis console here and show you. I've got probably 50 slides that actually walk through the entire process, but I think that would bore you to death. So instead, I will jump in and show you here. So as you can see on the left-hand side, we're actually breaking down our components into folder structures. So you can see we've got a main folder, and then we've got all the subfolders there, which are all triggered processes from the main process. So if I look at main, I apologize, the screen resolution is a little tricky on this one, but I'll get you through it. So we're, again, monitoring for new requests. Right? We're monitoring TFS for those work items, and those work items will contain all the data we need to actually act upon the process. And if I look, it's monitoring for that request, and then it's processing the input file. If I look at the process input data file, or policy, we've got a custom start because we've called it from another workflow, and then we're getting the work item, and we're gathering our variables from input. The gather variables is using PowerShell. And actually, what we're doing here, the previous item, the get work item, was downloading an attachment. It was downloading an Excel spreadsheet to a location on the action server. And then this PowerShell is actually going through that Excel and extracting all the parameters that we need for our process. You can see here that we're actually leveraging the file attachment path from the previous get work items. All right. So, and then last, we're publishing our policy data. And you can see we're publishing quite a bit of policy data back out onto the data bus for the main thread to leverage. Now, for those of you unfamiliar with how to actually enable that, if you right-click on the overall policy and click Properties, you can go into Policy Data, and you can easily click Add, type a name, select the type, and then enter a description if you like. Now, once you check that in, that data, that parameter is now available on the main thread for you to consume.
And with your PowerShell script, you can pipe that out as a variable, as a piece of published data in PowerShell, and then pick that up and publish it using the Opalis data bus.
Mm-hmm. All right. So we've now published our data, all our parameters back onto the main thread. We now look to configure our VM core components. Now, we are passing in parameters, our domain, our primary site server, our work item ID, our new server name. If we wanted to specify this parameter, we could go to subscribe and publish data. And the process input file has all our parameters. We can select one of those parameters to be able to pass it into the next sub-policy. So let me open up our VM core components. In this, we're using a combination of the TFS IP, some out-of-the-box Opalis IPs, as well as PowerShell. So we're using the get disk space status because we got to check disk space on the VM that we've been handed and make sure it has enough space to proceed with the deployment. Once that passes, we go to install our core components and configure WebDAV. All of these are PowerShell. All right, so if I pop this open, you can see some PowerShell here, and that we're again leveraging parameters that are on the data bus. The other thing of note here is that we're actually returning a string. If we return an error value based on the evaluation of the PowerShell, we're able to actually error out the process. Otherwise, the process would continue down the path. All right. At the end of it, we're updating our history, and then we're posting data back to the main thread. So we go back to our main thread. We're now building our config manager role. And in this, did I skip decom? I did. I skipped decom. All right, in this instance, we've got many sites that we're decommissioning an older server, a physical server, and we're replacing it with a VM. But we've got new sites that we're actually rolling out to that don't have a previous site to decommission. So we have some logic here that determines whether or not we should proceed down the path of actually decommissioning an old site, which this pathway is, or we route out back to the main thread because we don't need to decommission it. So I don't need to decommission for the example that I'm running today. So I will jump to the next item in the process, which is actually our config manager role. Now again, we're leveraging a lot of PowerShell in this, and we're evaluating right at the beginning whether or not it is a secondary site or a distribution point. Now, based on this evaluation, we're able to actually go and install a distribution point over a secondary site, depending on the data passed in. So for this example, I'm not going to run through each one of the PowerShell scripts because it will get a little bit redundant. So I'm going to jump out and, again, go to our next step in the main process. And you can see here, every time we exit out, we have an escalation on failure. So if an error condition is raised from the sub-process, we go and we escalate a ticket in TFS. Our next step in the process is replicating the package source. This, again, is leveraging PowerShell, as well as leveraging an executable. At the end of it, we're updating our status again, and then we proceed to a post-deployment QC. And that QC actually rolls out a test package to either our secondary site or distribution point and ensures that it's reached. So, as you can see, we've broken things down. At the end of this, the published data comes back to main, and we update TFS with success, or TFS with success. Very nice. As you can see, we've broken this down into subcomponents that are much easier to maintain, and we can identify success or failure for each of those components and escalate at any point along that pathway.
It's also a very real-world scenario where I get a lot of questions with people saying, oh, there's not an integration pack, or there's not an activity, I can't do it. You can see up here, this is a very real-world scenario. Charlie's team have done a lot of work with PowerShell. You may choose to use a different tool set. The integration packs and the IPs, and the activities within them are designed to get you going quickly with the major product sets and the major activities you're going to want to do. There are hundreds of thousands of different little things that you're going to want to do, and we're never going to have an activity for everything that you want to do. We are working on some pretty cool stuff that you will probably see later this year, which will make that task easier, particularly with PowerShell. But at the moment, it is just a reality that you're not going to have a ready-made icon to drag out for everything you're going to want to do. There's a lot of PowerShell in here, there's a lot of command line, there's a lot of web services and so forth. And that's the reality of automating in a very disparate environment. And hopefully some of the messaging you've seen around the Microsoft Private Cloud move and so forth is moving to a standardized world. But at the moment, it's very diverse, and there's lots of different things and lots of different solutions. So what we're working on is making that an easier transition, but it is a transition. And in the meantime, there's not going to be a nice little activity for everything you're going to want to do. But we want to provide you with the tools that allow you to easily build out and gap fill, which is why we're putting so much effort into things like the quick integration kit and PowerShell and so forth.
So I want to go into a little more detail on the PowerShell question. So I showed examples where we were leveraging parameters in the PowerShell script, but I want to show you, for those that are unfamiliar with how to actually add those, it's a right-click in the text file area. You hit subscribe and then publish data. Now I can go back to our custom start, which is what got all our parameters from the main thread. And in this case, I'm wanting the secondary site server. So I'm going to select the new secondary site server. Oh, and I clicked in too far. So I've clicked in the right spot now. And it's as easy as that. And so for each of these variables, I can associate a parameter from the data bus.
It's important to note that Opalis, the Opalis data bus uses a branching algorithm. So where Charlie subscribed to a piece of published data, if one piece of data comes back, it'll just execute once. But if it got 3 pieces of data, so it got 3 server names back, it will now branch out and run 3 threads, one for each name it got. This is really, really important when you start to get large amounts of information back. You want to flatten the data down and make sure that after you run something like getting a piece of information, if you only want it to execute for one thing, you need to filter all that information back down. Okay, so in that example, Charlie was subscribing to the new site server. If he got 2 server names back, it's now going to branch off and run it in 2 parallel processes. Okay, so it's a learning and making sure that when you go through the testing process that you are getting singular pieces of data, if that's what you want, or if you're getting multiple pieces of data, to be aware that it's now going to execute for every single one. And if you get 3 the first one, and then you have another piece of published data that also gets 3, now you're going to spin out 9. Okay, and this can get out of control really quickly. So testing and making sure that it's doing what you want is really, really critical, which is why we say do it in dev, do it in test before you go to prod. Okay.
So one way of...
No one's ever broken anything that way, have they, Charlie?
No, never. Right, so especially not Ryan, but one of the ways that you can avoid the issue of actually branching is to flatten the data that returns. Right, so instead of it creating 3 different threads with each of the pieces of data coming back, you now flatten that data and consume it as just one. All right.
You can also concatenate that data if you want as well. So if you're getting back 2 disparate pieces of information, but you actually want it as one string, then you can do all sorts of merges with text data in particular. So you can put together things like domain name / username. They may come back as 2 disparate pieces of information. You can go piece of text 1 / piece of text 2 concatenated together, and then leverage that as a new piece of information, which is domain / username. Okay, so all those tools are there for you to get all the information. You don't have to continue to do awkward text manipulations all the way through. Do it once and then carry on.
All right. So that was our config manager role deployment, which is in testing at the moment. As we look at our service management and IR, or service request and IR remediation, this is actually an example from the Xbox Live team. The example that they've just automated is a user account password reset. So there's multiple domains managed at Microsoft. In their case, they've got multiple domains in the extranet that they're actually managing to support Xbox Live. It's common for somebody to have an account that's become frozen because it was inactive for too long, or they forget their password and they need it reset. Today, those service requests are not automated and they're not tracked. Previously, they were not automated and not tracked. And they had no way of actually going back and checking other than going through someone's inbox to see who requested and what happened. As they looked at their solution, they identified that they not only needed to initiate a password reset, but in some cases check to see if the account was frozen and unlock that account. And then their goal is to eliminate all that manual interaction, right? The process of unlocking an account, resetting a password, should be automated from the request all the way through to completion. In their case, they are actually using just an ASP.NET front end on SharePoint, and they're collecting the user alias as well as the environment. And the environment in their case is the domain that they're requesting the password reset for. First, they're monitoring Service Manager. That UI that I just showed you is populating a new service request into Service Manager when the user enters it. When they detect that new service request, they're then going and extracting the details. From there, they're actually changing that username to the full email address. That's a query out to AD. Next, they're triggering a sub-policy. They're actually starting from the get-go with sub-policies. It's something that we took a month or so before we were executing. And in that sub-policy, they're generating a random string, which they're using as their password. They're next checking to see if the account needs to be unlocked, and they're unlocking it if necessary. And then they're resetting the password, and they're emailing the details back to the user. Now, if all that was successful, it compares values that are created in the previous sub-policy, and it goes ahead and resolves that. All right. So their goal with that, they actually estimated that it was at least a half a person for a full year just in their request. They have a large number of password resets that come through. Any questions on that?
Question over there.
How do you deal with security across domains? I've used Opalis a little, and I know you have to store account information in the workflow. If you have different domains and use different administrative passwords, how do you have one workflow that does all that?
So the way that we do that, good question by the way. No, they're very hard to catch, aren't they? The way that we do that is in the connection strings, and so all protected fields, the ones that have little asterisks when you type, are stored using an encryption key. So no passwords, so long as you've configured things correctly, will be stored plain text. And the way we do it is in connection strings. And each activity, you choose which connection string you're going to use. So, for example, pick Service Manager. Maybe you had multiple Service Manager instances. You could have 3 different connection strings for 3 different Service Manager environments, and each activity could point to a different Service Manager instance. So the activity is not tied to one global variable. It's tied to a particular connection string. And same for any other things, so sort of like Active Directory. You can have a connection string not only within one AD, maybe one's got read-only access because you just want to get info, and versus another account which has change access. So you can have multiple connections to one service, and you can have multiple connections to multiple services. And that's basically the way you break it down, is working out. And this comes back to Charlie's comment about understanding what it is you want to do and what the whole level process is, and reimagineering, as that term sort of goes, that what is the process you want to do, what is the right way to do the process, when is a manual step required, and so forth. Once you map all of that out, you get this big complex diagram, especially in some of the internal environments we have with global ADs and multiple domains and multiple segments within those domains and so forth. It becomes very complex, and mapping it out first before you start dragging icons out on the palette makes things a whole lot easier.
So being able to leverage the connections to config manager, operations manager, service manager is one strategy. For tasks that you're executing against a server or client that you're not going through one of those other products, you need to have the correct credentials, whether you store that in the actual policy, whether you maintain an action server, particularly with the credentials necessary to go execute those actions within the domain and only route traffic of the policies to that server. That's another way to do it. I don't believe we found any one best way. Do you have a comment, Jim?
No one best way.
Yeah.
Charles Joy, his PowerShell integration pack that he just released actually facilitates quite a bit of that as well.
So as Jim was mentioning, Charles Joy just released a PowerShell integration pack that adds some extra security there.
There's also, each activity that runs a command has its own set of credentials that are stored with it. And if you are creating your own integration packs, when you create the fields required for that activity, you can choose encrypted data as a field type, which means that you see asterisks coming through in the UI, and it means that it's stored in encrypted format inside the database as well. So unless someone's able to crack into your database for a start and then crack your algorithm, it's as secure as we can make it. Good question.
Okay. Anything else before I move on? No? Okay. Lastly, actually, not quite lastly, wanted to step through what we did when we looked at Opalis to implement within our environment. The value that we saw in Opalis and why we went down this path is we saw it as that one central place for our automation. It's that common platform that we can leverage our existing automation on, and we can actually orchestrate tasks across different products very easily. And it brings us closer to a level of commoditized IT that we'd like to get to within our organization. The Opalis architecture, for those that aren't quite familiar with it, consists of a data store and action servers. The action servers actually run the processes against, whether it be directly against the server or through an orchestrated product like Config Manager. The user interacts with Opalis through either the policy designer and the management server or through the operator console client, which is a web-based GUI. Now, what I showed you over here on the Config Manager role deployment, I was interacting using the policy designer. So, planning your Opalis architecture. When we looked at our environment, we've got two very distinct environments. We've got our server data center environment and we've got our client environment. And we had to analyze both to figure out how we were actually going to deploy this. On our server side, we started with some basic ping tests. One of the pieces of advice we got early on was that we should have our action servers no more than about 100 milliseconds away from whatever target server that we were operating against. So we started a series of ping tests from our data centers. And we ended up drawing a network latency map that looked something like this. As you can see, I've got three fairly large circles there in the middle in that 30 millisecond band. Each of those larger circles indicates large data centers with large numbers of machines. The smaller circles indicating smaller locations, smaller number of servers. In this example, we have a fairly nice system. We can actually implement our Opalis instance with a database in our central data center, and then we can implement two other action servers in different domains in other data centers. Now, because the majority of our machines exist within 100 milliseconds of those action servers, we think we have a very good shot of having good success when executing our policies. It's only those in that gray band that we thought we might have some issues with. So the architecture that we put in place looks something like this. We've got 2 action servers in our main domain, and then we've got a single action server in each of 2 other domains. On our client side, we did that same ping test, and the diagram looked a little different. As you can see, we've got a large circle in the middle. That's our central located config manager instance. And then we've got 2 other large circles, but they're far away from each other. And then we've got a lot of smaller locations that are about 500 milliseconds away from our centrally managed config manager environment. This is because a lot of our secondary sites and distribution points are in remote locations such as Africa and Asia, and they're smaller pipes. So, looking at what we could do here, we again can place our Opalis instance in our central data center. From there, the rest of our servers become target servers. But based on the early guidance that we got, we didn't think our chances of success against these other target servers were going to be that great. Now, we could implement secondary Opalis instances, bring up a database and action servers in each of those remote data centers that are larger, and that might increase our chances. However, it also comes with some overhead. There's not a very easy way for synchronizing your policies between Opalis database instances. And so it came with some overhead that we weren't willing to accept for our initial proof of concept and production work. So we decided against that, and instead we're just going with a single database and management server and an action server in our central data store with the goal of stretching Opalis to its limits, seeing how far we can actually execute successfully. How we looked at achieving that goal was building a policy to test this architecture, to determine the ability of Opalis to actually reach those machines and see, was that guidance correct? Do we need to have that action server within 100 milliseconds of a target server for successful execution? So we built a reach run book. It looks something like this. We initiate our process. We actually run this every 4 hours to check for varying network conditions. We create a database table if none exists. And then we get our list of servers to go and ping. And we not only ping, we actually check a server status. So we ping those servers. If the ping is successful, we now reach out and check service status on those same machines. And the results get logged into a data table in SQL, and we update the variance info from the previous run. Now, we ran this for several weeks. We analyzed the data, and the result was there wasn't really a direct correlation between the high latency and high failures. We actually experienced some failures in low latency conditions, and we had success, complete success, in some of our highest latency conditions. So what we found was that it was more packet loss, not latency, contributing to the runbook failures. And the blog up here is Jim's blog, and he actually has blogged in great detail about this Reach runbook and some of the results that we had. So we actually are seeing fairly good success in both our server and desktop environments, proving the latency issue was incorrect.
We are also doing a lot more performance testing on Orchestrator than we ever did on Opalis. So part of the release cycle between beta and release candidate involves a lot more stress testing, a lot more performance benchmarking, and our intent is to write that up as a white paper shortly after release, or hopefully with release if we can time it right, just to give people an understanding of the testing we've done, incorporating the real-world results from MSIT and having an IT showcase white paper about that. But also giving you a lot more guidance around it's not latency, it's packet loss, or packet loss versus latency and so forth, working out where the problems actually are. So we're in a slightly different scenario with Opalis being implemented in a dog food fashion internally than we typically would be with a Microsoft product. Opalis was developed in a small software shop. It grew up over a period of time. It's got a lot of different development standards than we would typically have in a Microsoft developed product. So a lot of the instrumentation required to do this performance testing simply doesn't exist in the product. And so these guys really are taking it well beyond where it's ever been before, and going into an environment of a scale that has never been used that way before. We know who's running Opalis in the world, and this is probably 4 or 5 times larger than the largest environment we had previously. So, this is pretty big, and it's great. The work that they're doing, we hope that you will get to learn from this and can benefit from it as well.
All right. Some of the lessons that we learned over the course of operating Opalis and developing our Opalis runbooks, the key is making sure that you design and paper test those business processes. Solid business process will automate very well. If you've got a buggy process, it's just going to cause bugs more quickly. Right?
And it breaks stuff more quickly too if you've got it wrong.
Yes.
Was anyone at MMS? Did anyone come along to MMS? No one, good. So we had a customer up on stage, General Mills, who implemented Opalis in a client scenario. And one of their learnings was quite simply that for every hour that the automation engineer spent inside Opalis creating the runbook, they spent about a month of time working through what the process actually was. It took them about 60 days of business time to work through what is the process that they wanted, who signs off stuff, what is the actual process, and then optimizing the process to cut out a lot of steps that either weren't required or the wrong people were involved. That translated down to around about 60 hours of time inside the console to make it work. Okay, so you're going to spend a lot more time thinking about stuff and a lot less time building stuff. You can still spend time building it, but as Charlie says, the reality is if you build a workflow that has 10 steps, but they're 10 bad steps in the wrong order, you're just going to do something in a poor way really fast, and you're going to get a lot less benefit than if you do the process up front.
Thanks, Adam. Next, break down policies into smaller components. I hope you saw the stark contrast between one of those first policies that we developed and what a bear that is to actually manage and maintain. The other benefit of breaking them down is you're going to improve the scalability of your action servers. If you're holding that much data on the Opalis data bus, that's going to bog down that action server.
No one's asked the question about how many runbooks are executing on the action servers yet. I'm surprised. The answer is it depends.
Next, make sure to build an initial framework. When we first started out, we were going in several different directions, and it really took some experimentation for us to figure out how we should go about building those runbooks. But once we did, we're putting some framework in place so that other folks that are now joining the team in developing the runbooks have that initial framework and don't have to go through the initial learnings themselves. And then the other lesson learned there is on the change control. Implementing something through source control, whether you use TFS or some other source control, that will give you that level of change control.
I think there's also a question that comes up from time to time is when you develop an integrate, why would you develop an integration pack and move some of those PowerShell scripts and activities and command lines into activities inside integration packs? And that comes down to change control as well. When it's just a script on a file share, anyone with access to that can go edit it and change it, and you may or may not be aware that the script's been changed. If you move that script into an activity inside an integration pack, you have a certain level of change control by default, simply because in order to make a change, you have to update the integration pack, which means you then have to redeploy it. That is a change in effect because Opalis captures the fact that the IP was redeployed, and typically this is kind of like an enterprise admin role where not many people have authority to do things like that. So simply by moving your scripts into activities inside integration packs, you're going to get a lot of change mechanism around that as well.
And then lastly, providing some base training for your engineers, PowerShell as well as some C# basics for creating custom IPs is key. And then teaching them some of those best practices that sort of goes hand in hand with that initial framework. Have some getting started links up here for you. that include Charles Joy's blog as well as Jim's blog. There's the Opalis resources at the top.
That's the one.
That actually has a number of resources out there for you and some links to, I believe, Coplex as well as the, what was that, TechNet Gallery. That's the next slide. And that is it.
So a point you want to make is when Charlie jumped out and did the live demo, all the screenshots of what he went through are in the deck. So everything you've seen, all those screenshots, this entire set of slides is available for download. Okay, so if you want to go back and take a look at what we actually did in the steps we went through and have a look at that, all of the slides are there. It's a pretty big slide deck, but it's just lots and lots of screenshots. So it is all there. Another thing I'd add is that from an internal perspective, we have a solution accelerator team. And that team is ramping up on Opalis a lot as well. They are helping us build some more integration packs, and they are actually building an automation team who are going to start building out default runbooks that will become available for lots of products. So if you think about things like Exchange and SQL and SharePoint, where they have a very rich interface through PowerShell and other mechanisms, we're going to start building out a lot more runbooks to provide them in a library format so you can just import them and have 80% of what you need out of the box. So we're invested in getting you quickly going as well. So that's all the information we have. If there's any more questions, now is a good time. Yes?
Do you have any integration packs for other ticketing systems other than Service Manager?
So we have, if you come to the overview session tomorrow, we have 28 integration packs out of the box. BMC Remedy, CA, AutoSys, I think it's called, and so forth are in there. So I've got the complete list. If you go to www.opalis.com, it will warp you to the Opalis site on System Center. And in there's the complete list with all the activities as well. Yeah. Question over Fassa.
What's your commitment to the high-level management packs like Remedy and whatnot?
So I'm going to answer that question tomorrow, but I'll answer it now as well. We are committed to it. We, from a Microsoft standpoint, are working very hard to make those integration packs work. We have agreement with a number of those companies already, and we are actively working on them. Active Directory, FTP, VMware vSphere, and IBM Tivoli are being updated in the orchestrated beta timeframe, so those have actively been worked on now. Some of the other ones are a little more challenging from a logistical point of view. My request is that if you want those IPs, please tell the third party that you want the IP updated because the blockage is not on our side. Good question. They bounce kind of well, don't they? Awesome. Any other questions? Well, thank you very much, guys. We hope that was useful, and please let us know if there's anything more we can do to help you get going. Thank you.